So I'm going to talk about live papers, which are a somewhat experimental tool in eBrains to really focus on the R in FAIR, how we present our data for people to reuse. So a brief history of scientific communication. It all started with scientists just writing to each other and putting it in the mail and waiting months until the reply came back. Things got a lot better with the invention of scientific journals, first in paper form, also took a long time to be delivered to your institute. And then again, got much faster with things like PDFs. And now, while we still use PDF widely, our papers are now mostly in HTML and associated technologies on the web. So there's been a great many steps forward in terms of how accessible the paper is, but nevertheless, there's still a lot that's missing from this, which can perhaps be summed up by one particular phrase: "Data are available from the authors upon request." And I don't have to comment on how rarely that actually works out. So, can we do better? What we want to do is provide not just the text, not just the description and a few figures and a few statistics, but really everything which underlies that, so that people can try things out for themselves. They can test your analysis, check everything is correct, reuse your data to do new, novel things. Now, there are various existing tools for interactive scientific documents like this. Jupyter Notebooks, of course, and things building on top of Jupyter Notebooks, like the Executable Books project, for example. And this has been going on for many years. There's this Grand Challenge workshop which took place in 2010, 2011. So it's a long time that people have been trying to build this kind of thing, and yet we still haven't really got any mainstream platform for doing this. And I think there are some reasons why it's been hard for this to take off. Most of the existing solutions really support, they're interactive in the sense that you can run simple, small code snippets, but not much more than that. It requires a little, if you need a lot of computation for your code, then that's not going to work too well if you don't have access to a supercomputer in your back garden. Another challenge is reproducibility. Of course, anything involving computational workflows is very dependent on the version of the operating system or the versions of the libraries that you're using. And so code which worked 2 years ago probably won't work today. Similarly, many of these platforms are very short-lived, ephemeral. We need some kind of guarantee that these things will still work, these live papers will still execute in several years' time. You can open a PDF created 20 years ago and you can still read it. We need the same level of persistence for live papers. And then the final challenge I've identified is authoring tools. Creating these things often requires a very high level of technical competence, which is distracting from the normal work of a scientist. You can't just open up Microsoft Word and create an executable document. So we need better authoring tools. And so one approach we've taken to try to address some of these challenges is to use the eBrains infrastructure, because eBrains provides many of the things we need. We need persistent scientific data storage, some computational resources, a lot of web-based tools and services for doing digital neuroscience, reproducible computational environments, and sophisticated metadata handling based on the knowledge graph, which Oliver presented earlier. And one of the big wins of that is that we have automated links between the research objects, the data, the code, models, and the web services and other tools which work with those. And so the users have a very simple path. They just have to say, okay, I want to show this data, and then the business of connecting that to appropriate tools is handled for you by the system. So the eBrains Live Papers platform, you can find on the eBrains website at this slightly strange URL. So good they named it twice. And essentially a live paper is a a number of sections which contain a mixture of text. You can use Markdown, you can use LaTeX for formatting. Sections which contain data display or model simulations as embedded widgets, and sections which contain link out to other tools or data download, and so on. And so by combining these different sections, you essentially end up with an interactive paper. So ideally, I would give a demo here, but I think we don't really have time. So instead, I'll show some screenshots from a video tutorial prepared by Shailesh Apukutan, which you can find linked from the eBrains live papers site. And so this is an example of one of the live papers which we published a couple of years ago. It's linked to a traditional paper, but it adds extra interactivity. And so in the live paper, we have the basic normal metadata, we have an abstract, and then we have a number of resource sections which contain a mixture of text and data. And so if we click on the morphologies tab, for example, it opens up a list of all the neuronal reconstruction files that were used in this paper. For each of those, we can download them, or we can actually view them in one of the eBrains web services, which is a morphology viewer. And this is automatically linked, so that when you click on this link, it will open up this particular file. Similarly, on the electrophysiology tab, we have an embedded tool which visualizes the traces, the recordings that were actually used in this data. And we can even go as far as to link to run simulations within the live paper. So if you click on this button here, it's going to open up the BlueNAS Neuron as a Service neuron simulation tool. You can actually run simple simulations in your web browser. And finally, we have Jupyter Notebooks here, which we can clone into our own environment to have our own copy, which we can then change and modify. Click on the button, you have to copy it to your eBrains account, and then you can run the Jupyter Notebook. There are other tools which have as well, protein structure, visualization, and a couple more which I haven't shown here. So to sum up, we have these tools as embedded widgets, the Neo viewer and the protein structure viewer. And then for other tools, we have link outs. So for Jupyter Notebooks, morphologies, simulations, and the model catalog for looking at validation tests. And I think what makes this really easy to use is we have an authoring tool. So it's the first version of this, you have to write your own HTML code. Now we have a tool. So you go to the website, you can create a new one, you can load it from a local file, or you can load it from the knowledge graph directly. And how this works is you start off by adding basic metadata, the title, the authors. If you already have something which has that information, like for example, if you use a live paper as supplementary data to a traditional published article, you can just upload the PDF or put the DOI of your preprint, let's say, and it will import the metadata from your preprint. You can edit it manually. And then the interesting part is you can then gradually add these sections. You add multiple sections. Each section you can add text. You can select data you want to put in that section. You put code you want to put in the section. When your live paper is complete, you can view it, you can download it, save it to a suitable file format, or you can submit it to be published. An example of what this looks like for adding data from a public resource. If you want to look for data in the knowledge graph, for example, then you have a nice search interface where you can find the particular files which you've already shared through eBrains, but now you're going to showcase them in your live paper. And in addition to the eBrains knowledge graph, we also have support for neuromorpho.org, the Allen Brain Atlas, and then for models, we have ModelDB, Open Source Brain, and biomodels. And in principle, you can add a link to any persistent, reputable public data resource. Once the paper is complete, you just request this to be published. There are then some quality control checks, are all these data shareable? Are we allowed to share them? Do you have a license which lets you share them? The live paper is then published on the eBrains site and gets a DOI to DataCite. Or if you're not quite ready to publish it yet, if it is supplementary material for a manuscript that's under review at some journal. You can share the live paper with the reviewers of your manuscript by setting a password and give the password to the handling editor for your manuscript. So to sum up, live papers complement sharing of research objects, whether that's data, model, code, or whatever, by firstly connecting these objects with a narrative structure and additional context, and further providing interactive tools and widgets to let other people work with and explore your data. Because this is built on the eBrains infrastructure, it means that these tools and services will continue to be supported and maintained, even if the original developers of them are no longer around. The eBrains, as an infrastructure, will continue to maintain them. These things get a DOI, so you can put them and you can reference them easily. You can link to many other resources, not just the knowledge graph. And finally, is to say that all the code for the live paper platform is open source, and we very much welcome new collaborators. We have a lot of things we're still working on, adding more widgets for other data types, linking out to more web services. So eBrains has 20 or so different web services that exist, and we don't yet support all of those, so we're working on that. And of course, there are many other web services outside eBrains we'd also like to integrate with. So again, collaborations are welcome. We want to make the authoring tool even easier to use. In particular, we'd like to find a way to deepen the integration with Jupyter Lab, Jupyter Notebooks, so that you don't have to jump out of the live paper to go to the Jupyter paper, but somehow to have these things all embedded in the same structure. That's a more long-term plan. So I'm finished. I'd like to thank the EC for funding the Human Brain Project, and these are my collaborators who worked on developing this platform. Happy to take questions.
Thanks, Andrew. Great. That was very interesting. Perhaps you could stop sharing your screen, and then we can see if there are anyone either in the chat or walking up to the microphone to come with a question. So, any questions for Andrew? So while we wait for that, maybe we could, maybe I could ask you about the liveness of the papers, right? So the concept is live papers. You have interactive, or you have a lot of resources coming in, but they are in fact published and receive a DOI, so that if it is indeed live and changes, then there will be a new version, or how is that dealt with?
Yeah, that's a very good question, Trooper. Yeah, I mean, they're live in the sense that people, for example, if you can dive into the data, the electrophysiology recordings, you can look at them in detail, and so you can drill down to a much finer grain level of detail than you could get in a more static document. As far as people building on that, changing the code in the notebooks, creating new papers, that's something I haven't really thought about, how to simplify that process. So yeah, I think I haven't got a good answer to that question, but I will think about it.
Okay, thanks. We move on to a question from Marianne Matone. Paper and stone last for thousands of years. Bits and bytes do not so much. How do you deal with the longevity issue?
Yeah, it is probably the major challenge of this. This is the reason for embedding this within eBrains, which will hopefully have substantial longevity. It has the Human Brain Project is now coming to a close. eBrains is taking over with funding, some funding from the EC, but largely funding from international governments, and it's on the S3 roadmap, the European Research Infrastructure Roadmap. So what we would hope for is to have longevity like CERN, for example, which has been going for quite a few years now. And so in terms of the resources to support this, that's I think it's essential. This kind of system is built on something which has a long-term perspective. In terms of things still working, so one of the major projects within eBrains is to develop a standard set of tools and packages which are versioned and reproducible based on the SPAC package manager. And so the idea is that you should be able to you should specify, okay, this tool uses the eBrains packages from September 2023. And so those packages will still be available. You can go back and still run things even 5-10 years in the future. Though that's the ambition, we'll have to see how well it works out.
So please take the questions from the chat.
So question from Yarek. Is the platform easy to reuse or deploy for another use case? It depends how distant your use case is. At the moment, it doesn't have terribly tight integration to the eBrains knowledge graph. The underlying data structures are fairly simple. It builds on OpenMinds schemas. The OpenMinds has a publication module, which is intended to make it possible to represent live papers in a very generic way. The code itself is open source that we deploy through Docker. So yeah, I'm happy to talk about that. Question from Matthew: what's the process for having your repository added? You mean your repository in terms of a data source? Yeah, just ask us. So send a message to eBrains support, and we can discuss. I mean, if there's an API, it should be quite straightforward to do so. So happy to talk about that some more. And then question from Marianne: how does this compare to the Aperture platform of CONP? I don't know, but thank you for the reference. I shall look that up.
Okay, thanks, Andrew. Do we have any other questions from the audience? If not, I think we are in time to close this session. I'd like to thank the 4 speakers for contributing to the session. They went up to the task with not too much notice. So I'm really grateful for you for stepping up and delivering this. So thanks a lot. Thanks for listening in. And I think we can close this.